In this video, we're going to learn how to rationalize the denominator of your fraction. Now, this is really just a convention. There's nothing wrong with a fraction like 1 over the square root of 2, but the square root of 2 is an irrational number, and so we can turn that denominator into a rational number. In order to do that, we are going to use that number itself. So notice what I did here was I took square root of 2 and I multiplied it with square root of 2, because the square root of 2 squared is going to get back to just 2, which is a nice rational number. If I multiply by square root of 2 on the bottom, I have to multiply by the square root of 2 on top. That is what I can do in order to not change the value of my fraction. I'm multiplying by a big invisible 1, and so I multiply it on the top and bottom. I now have this fraction, square root of 2 over 2, which is equal to 1 over square root of 2. It's really just sort of the way we prefer to write them. So let's practice this with 4 over square root of 10. What could we multiply square root of 10 with in order to make it a rational number? I need to multiply it with itself. Since this is a square root, if I multiply it with itself one time, that's going to undo that square root. So we are squaring the square root of 10, and we get back to just 10. On the top we have 4 root 10, and this time we're not quite done, because the coefficient out here and my denominator have a greatest common factor that's more than just 1, so I can simplify this fraction. 2 goes into both 4 and 10, so if I divide out from both of those, I'm going to have 2 root 10 over 5. Now we're just going to do a little bit more practice with this same concept. 3 over root 12, we're going to approach the same way we did 4 over root 10. We're going to multiply by root 12 on the top and bottom, which gives us 3 over root 12 over 12, and now we could simplify this. 3 goes into both, so we have root 12 over 12. However, if you already know how to simplify your radical expressions, you probably know that you can take something out of that root 12. So let's go ahead and do that. And honestly, we could have done that from the beginning if we would have preferred, but square root of 12 is the same as square root of 4 times 3. And I know what the square root of 4 is. It's 2, so this becomes 2 root 3 over 12. And I can simplify that even further by dividing 2 out of the top and bottom. All right. On this next one, I have a more complicated denominator. I have 3 plus the square root of 2. And so that's a rational number, 3, being added with an irrational number, square root of 2. And when you add an irrational to a rational, it's going to stay irrational. So we need to get rid of that. So we're going to use that very special format that we've seen when we were factoring, which is the difference of squares. If you remember, a squared minus b squared always factors to this very nice thing, a plus b times a minus b. So what I want to do is I need to multiply this by something, but because it's a binomial, if I just multiplied it with itself and I did 3 plus root 2 times 3 plus root 2, I would have 9 plus 3 root 2 plus 3 root 2 plus 2. So I'm going to still end up with that irrational term in it, and I don't want that. I don't want that middle term. So I want to use this difference of squares and use that to figure out what I should multiply by. So what I'm starting with here is an a plus b. So if I want to end up with a squared minus b squared, I'm going to multiply this with a minus b. And I have to do that on the top and bottom in order to not change the value of my fraction. So I'm going to now have 14 times 3 minus root 2 on the top. And on the bottom, since I have something plus something times that same something minus that same other thing, I now can do a squared 9 minus b squared. And remember, square root of 2 squared is just 2. So I didn't FOIL out or distribute out that 14 yet because I saw this coming. You might not have, that's okay. 9 minus 2 is 7, so I can actually just cancel this guy right here. I have 2 times 3 minus root 2. Now I can distribute this. I have 6 minus 2 root 2. Either of these are probably fine. It depends on your teacher's preferences. Down here, we want to focus on the denominator because that is what we're trying to rationalize. So we're going to use difference of squares again, but this time I have my a minus b. So I'm going to have to multiply it with a plus b on the top and the bottom. That is going to give me, on the bottom, my a squared minus b squared. And on the top, I have a mess, like a lot of stuff really here. Let's try foiling that out though and see what happens. So I've got 25 plus a 5 root 3 and another 5 root 3 is going to be 10 root 3 and a 3 at the end because root 3 times root 3 is just 3. Down here I have 22. So I'm ending up with 27 plus 10 root 3 over 22. And my last step would be to see if there's anything that could come out of all of my terms. If there's something I can simplify, it needs to divide out of all of my terms. And when I say that, I mean it has to come out of 27 and 10 and 22. Like I could cancel a 2 out of 10 and 22, but I can't cancel that out of 27 and 22. So this is about as simple as it's going to go. We can't simplify this any further. When you sit down to these problems, remember that you want to multiply a radical term just with itself, right? We did square root of 12 times square root of 12 in order to get back to just 12, which was a nice rational number. When you have a binomial, a number added or subtracted with another number, and one of those is irrational, now you want to remember back to your difference of squares and figure out what do you need to multiply it with in order to cancel that middle term so that you won't have any of those irrationals left over.